Hello viewers, moving on to the next question. This is K225 electrical engineering solutions from subject electric machines. In this video we will covering the details video solution to the question of 44 of 2 marks MCQ type that have been the master in the K225 electrical engineering. Question number 45 and the master question paper of K225 electrical engineering from subject electric machines is from DC series motor and is as follows. A DC series motor with negligible series resistance is running at a certain speed, driving a load where the load torque varies as cube of the speed. The motor is fed from a 400 volt DC source and draws 40 amperes armature current. Assume linear magnetic circuit. The external resistance that must be connected in series with the armature to reduce the speed of the motor to half is closest to. Options are given as A 23.2, B 4.82, C 46.7, D 0. Let's move to solution to this question. So basically DC series motor with linear magnetic circuit. What do we have? Phi is proportional to armature current IA. Right? For linear magnetic circuit for DC series motor. Okay. Is given as the negligible series resistance, that is RA is negligible to 0. So initially it is terminal voltage is given as the DC voltage given, and initially as there is negligible internal resistance or armature resistance, the EMF, induced EMF or the back EMF is also 200 volts at no load. Right. Okay. Right. Let's say the mode of speed was n or something. Let's say n. Okay. Now we have to reduce the speed to n by 2, is to half. For the DC series motor, it is given the load torque TL varies as cube of the current, that is IEQ. You already know that load torque is, or the electromagnetic torque is proportional to phi into IA. As phi is proportional to IA for linear magnetic circuit, so electromagnetic torque is proportional to IA square. Now for steady operating conditions, TL, the load torque should be equal to the developed torque, that is motor developed torque TEM. So basically what? Sorry, second cube speed. Cube. For steady operating conditions, what we have? TL equal to TM. The load torque should be equal to electromagnetic torque, so the motor behaves, operates steadily. So if we equate these two conditions, then we get that the speed cube should be proportional to IA square. Or in other words, IA should be proportional to n to the power 3 by 2 or 1.5. Right? To reduce the speed to half, IA should reduce to n prime equal to n by 2. IA prime should be equal to n by 2 to the power 3 by 2. Right? So n by into IA. Yeah, so basically Ia prime equal to n by 2 times, it is n by 2, sorry, not n by 2, n by n by n, that is half. Sorry, psi is proportional to n to the power 3 by 2. So Ia prime by Ia should be equal to n prime by n to the power 3 by 2. Now n prime equal to n by 2. So we have n by 2 by 2n, that is 3 by 2, that is half to the power 3 by 2. Or what we get? Ia prime equal to Ia by 2 root 2. ओके, ठीक है। I by 2 root 2, so I prime will be what? 40 by 2 root 2, that is 10 root 2 amperes, right? Also we have back EMF is proportional to phi into n. We know set it here. Back EMF is proportional to phi into n. ठीक है? For the series linear magnetic circuit, we have phi is proportional to Ia, so it is proportional to Ia into n. Now Ia is proportional to n to the power 3 by 2. Got it from here. So this is proportional to n to the power 5 by 2. Okay. Now n becomes half. Eb becomes what? Eb prime equal to Eb into half to the power 5 by 2. That is Eb by 4 root 2. Right. So the putting the value of Eb initially, it is from Eb no load, is 400 volts. So finally it becomes 400 by root 2, 4 root 2, that is 50 root 2. Okay. So we can find the current as Eb prime equal to V terminal voltage remains unchanged minus Ia prime times Ra external. Ra is 0, but there is some Ra external. Ra external that needs to be applied, inserted, connected in series. So Eb prime, if you put 50 root 2 equal to 400 minus Ia prime. Ia prime is what? Found in this case. Ia prime will be what? Yeah, for 10 root 2. So 10 root 2 times R external. From this, here we can find R external as for 400 minus 50 root 2 of what? 10 root 2. So we get this as 20 root 2 minus 5. So if you put the values, we get 20 root 2 minus 5 as nearly equal to 23.28 ohms. So this is option A. So by using basic relations for this DC series motor and linear magnetic circuit, I have first derived the relation between torque and the speed and armature current. Using that, we reduce the speed to half, the corresponding armature current has been found, and then from that, using the back EMF relation, the corresponding back EMF, and hence the external resistance that has been connected in series, the armature, to reduce the motor speed to half, has also been found closest to 27 to it is option A. Hope the solution is clear and comprehensible. If you have doubts or queries for this simple solution, please feel free to ask in comments. And that's all for this question. Thank you.